In this reference guide, we'll be looking at our next method of factoring, which is called decomposition. When factoring by decomposition, it's important to note that this is kind of your last resort for factoring trinomials. The first thing that you're going to want to do is check to see if there is a GCF. We looked at greatest common factors, or GCFs, in an earlier reference guide, and that's the first thing that you're going to try to do. If there is no GCF for the expression that you're factoring, you then try to use product sum. If you can't use product sum, which was the topic of our last reference guide, then you would use decomposition. This is the third and final way we're going to look at factoring in this course, and this method of factoring is a little more complicated than some of the earlier methods, but this will allow you to factor expressions that have a lead coefficient. And you'll notice at the top of this reference guide there's two terms. The first of which is lead coefficient, which is what a term I just said. So a lead coefficient is the number that appears in front of the variable with the largest exponent. So when we're looking at trinomials in this course that have a term that is an x squared term, it will be the number in front of that. So for example, if we were looking at the expression 3x squared plus 8x plus 5, our lead coefficient is the number that's in front of the variable with the biggest exponent. In most cases, that exponent will be a 2. So our lead coefficient in this example would be 3. The next definition is one that we've talked about multiple times, and that's a constant. A constant is a number that appears in a simplified polynomial that does not have any variables. So it would not have an x or a y. In the example that I've written above in red, our constant would be 5. It appears at the end. And it's important to order your trinomials in this way. You want your biggest exponent first, your next biggest exponent in the middle, and your smallest exponent, if there is another variable, at the end. And if there's no variable on a number, if it's a constant, then that goes at the end. With decomposition, as I mentioned before, that is the process we use when there's no GCF and you cannot use product sum. So you'll notice that the trinomials that we'll be factoring with decomposition look a little bit different than they did when we were factoring with product sum. And the big difference is what happens at the beginning. Now there's going to be a coefficient at the start, or there will be a lead coefficient. So if we consider the trinomial 3x squared minus 13x plus 10, it's important to remember these definitions that we looked at the top of the reference guide. So the 3 in front of the x squared is our lead coefficient. The 10, which appears at the end, doesn't have a variable attached to it, meaning there's no x. That's our constant. And you'll notice with decomposition that there's always a sequence of steps that you follow, and that sequence of steps will not change. The numbers may change, the variables may change, but you always solve decomposition problems in the same way. And the first thing you're going to do is you're going to multiply your lead coefficient by your constant. And you can see that I did that there under step 1. I took my lead coefficient of 3, and I multiplied it by my constant of 10, and 3 multiplied by 10 is 30. Easy enough start. That will always be the first thing you do when solving problems by decomposition or when factoring by decomposition. The second thing you're going to do is you're going to take the number that you found in step 1, which was 30, and you're going to write or list all the factors for that number. So for positive 30, there's positive 1 and positive 30, positive 2 and positive 15, positive 3 and positive 10, positive 5 and positive 6. And some people stop there, but don't forget that a negative multiplied by a negative will equal a positive. So negative 1 and negative 30 are also factors of positive 30. Negative 2 and negative 15 are also factors of positive 30. Same with negative 3 and negative 10, and negative 5 and negative 6. So in total, you have 8 factors for the number positive 30. From that list, you're going to do something that seems kind of like product sum. You're going to choose the two numbers that add to give your middle coefficient. our middle coefficient in the expression was negative 13. So from the list of 8 factors we just looked at, there exists a pair that add to give negative 13. And it's negative 3 and negative 10. Negative 3 plus negative 10 equals negative 13. And now this is where decomposition gets a little bit tricky. You have to decompose, if you will, the middle term, and you're going to write it as the sum of those 2 factors you've identified as adding to the middle term. So we're going to rewrite negative 13x as negative 3x plus negative 10x. But we have to be careful on order. We want to pair numbers that will work well together. So when we're rewriting our original expression, we're going to keep the 3x squared the same, just as it was in the original expression. We're going to keep the positive 10 at the end. That constant will remain the same as well, just as it was in the original expression. What happens in the middle will be different. Instead of writing negative 13x, we're going to write negative 3x and then negative 10x. Now, we want to pair numbers that work well together. 10 and 3 don't divide nicely into one another. We would get a fraction. But 3 and 3 do, and 10 and 10 do. So we're going to pair the 3x squared with the minus 3x, and we're going to pair the positive 10, the constant, with the minus 10x, because again, we want numbers that work nicely together. And you'll see why in 1 second. Now, you're going to divide your 4-term polynomial in half with a dotted line, and you should actually write that dotted line in. You're going to factor what's on the left-hand side, and you're going to factor what's on the right-hand side by pulling out the GCF for each side. And that's going to leave you with something that looks like this. So we had a GCF of 3x in the expression to the left of the dotted line. When we divide each of those terms, so again, we're thinking back to how we factor by GCF. We divide 3x squared by 3x, we get x. We divide negative 3x by 3x, we get negative 1. Then we do the same thing on the right-hand side. So we factor out a negative 10. It's important to take the same sign as that which is attached to your x value, so the coefficient in front of x. So it's negative in this case, so we pull out negative 10, and it leaves us with x minus 1 in brackets. What we want is what has happened. We want the same thing in the brackets, because that's going to be one of our factors. If you get something different, if what's in brackets on to the left is different than what's in the brackets to the right, it means you've made a mistake, and you can go back and identify that mistake, correct it, and then carry on with the problem. But what you'll notice is what's inside the brackets, that's one factor. You can see x minus 1 is a factor. And what's outside the brackets, so in this case 3x and minus 10, that's your other factor. And so that means that the factors for the original expression, 3x squared minus 13x plus 10, are 3x minus 10 and x minus 1. Well, how do we know if that's right? How do we know that we've done that question correctly? And the nice thing is, with these problems, you can always check and make sure you've done them right. And you're going to check by using the distributive property. So that means we're going to multiply 2 binomials. And we do that by distributing each part of the first binomial by each part of the second binomial. So we start by multiplying 3x by x, which gives us 3x squared. Then we multiply 3x by minus 1, which gives us minus 3x. Minus 10 by x gives us minus 10x. Minus 10 by minus 1 gives us plus 10. And then we combine like terms if they exist, and they do. Minus 3x and minus 10x give us minus 13x plus 10. And now what you want to see happen is you want your solution, when you use the distributive property, to equal the original expression. 3x squared minus 13x plus 10, 3x squared minus 13x plus 10. And if that happens, you can be very confident, about 99.9% confident, that you've solved the problem correctly. So doing those checks, even when it's not mandatory, is useful, because you can check to make sure you did your answer correctly. All right, so now on the back of this reference guide on page 2, there are 4 problems. We're going to work our way through these problems, and we'll recap the steps, and by the end, hopefully you'll have a good handle on how to do them. So, The first thing that we do is we take our lead coefficient, which is 6, and we multiply it by our constant, which is 3. Both are positive, so it gives us 18. So positive 18. Now the factors of positive 18 are 1 and 18, 2 and 9, and 3 and 6. But we have to remember that the negatives also are possible. So negative 1 multiplied by negative 18, negative 2 multiplied by negative 9, and negative 3 multiplied by negative 6. From this, we have a list of 6 factors. We choose the ones that add to give us plus 11. That is our middle term. So plus 11, those factors are 2 and 9. So we disregard the other 5. Now we're going to rewrite the expression, 6x squared. We keep the beginning, and we decompose the middle. So we have to make a decision. 6, does it work well with 2? Well, yes, it does. Does it work well with 9? It does, but not quite as well. 6 and 9 have a common factor, but they don't divide evenly into each other. We'd be left with a reduced fraction, but they wouldn't divide perfectly into one another. So we're going to choose to write the 2 first, which means we pair the 9 with the 3, and 9 and 3 do divide evenly together. So that should work out nicely. So now we draw our dotted line down the middle, and we factor the left and we factor the right. The GCF of 6x squared and 2x is 2x. And then we divide each of the original terms by the GCF. 6x squared divided by 2x will leave us with 3x. 2x divided by 2x is equal to 1. Now, that means that when we pull out the GCF on the right-hand side, what's left in the bracket should be 3x plus 1. So let's see. The GCF of 9x and 3 is 3. 9x divided by 3 is 3x. 3 divided by 3 is 1. And now we can see that that did happen. We have the exact same thing in the brackets, which is great. So we know that our factors are what's outside the brackets, which is 2x plus 3. That's one factor. The other factor is what's inside the brackets, which is 3x plus 1. Okay? If you wanted to check it, then you would just use, as we did before, the distributive property and make sure that you end up back where you started. So if we wanted to check this one, we would take 2x and distribute it amongst both parts of the second binomial, and 3 and distribute it by both parts of the second binomial, which gives us 6x squared. 2x times 3x is 6x squared, plus 2x, plus 9x, plus 3. When we combine our 2x and our 9x, we get 11x. And that should give us our original term, and you can see if you look up that it does. So that's our first example. Now let's move into our second one. 5x squared plus 14x plus 8. So we start by multiplying our lead coefficient by our constant. So we're going to take 5 and multiply it by 8 to give us 40. And now we want the 2 factors of 40 that add to give plus 14. And maybe you can do this in your head, and if you can, you don't have to list all the factors. But I'm going to, just to make sure that we're all on the same page. And I get these values. Now, I could list all the negatives, but I can see that my answer is there. So negative 1 and negative 40, negative 2 and negative 20, negative 4 and negative 10, and negative 5 and negative 8 are all factors. But if I recognize that 4 and 10 add to give me 14, well, I can just stop right there. So we're going to take 4x and 10x, and we're going to decompose our 14x. So we need to decide if we pair the 5x squared with 4 or the 5x squared with 10. Well, 5 and 10 go nicely together. So that's what we're going to do. We're going to write our 10 first this time. So 5x squared plus 10x plus 4x plus 8. So the expression remains the same in terms of the beginning, the 5x squared, and the constant, the 8. It's the middle that we change. Then we draw our dotted line, and we factor. The GCF of 5x squared and 10x, that will be 5x. 5x squared divided by 5x is x. 10x divided by 5x is 2. So that means when we factor the right-hand side, we should get x plus 2 as one of our factors. So the GCF of 4x and 8 is 4. 4x divided by 4 is x. 8 divided by 4 is 2. So again, we get the same thing in brackets. That's what we want to have happen, and it has. So that will be one of our factors, and what's outside the brackets, the 5x plus 4, will be our other. And you can go ahead and check that using the distributive property if you'd like. I'm not going to check this one. Some questions will tell you to, some won't. It's always a good idea to do the check, but it's not mandatory unless the question says to. You're welcome to check that on your own if you want to make sure that everything lines up. So our next ones, C and D. So with C and D, C is 12x squared minus 11x plus 2. So we start by multiplying our lead coefficient by our constant. 12 multiplied by 2 is 24. So our factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6, negative 1, negative 24, negative 2, negative 12. And we get a list of 8 factors. Again, we're choosing the pair of numbers that add to give us negative 11, which is negative 3 and negative 8. Now we have to decide how we're going to arrange our numbers. Do we put the 3 first or the 8 first when we decompose negative 11? Well, 3 and 12 work nicely together, and 8 and 2 work nicely together. So it makes sense to put the negative 3 first. So when we do that, we're going to have 12x squared minus 3x minus 8x plus 2. We build our wall between our first 2 terms and our second 2 terms, and we factor each side. Well, the GCF of 12x squared and negative 3x is 3x. That leaves us with x minus 1. Now, again, we're at that checkpoint. Our second side, or our right-hand side, we should have x minus 1 as one of our factors. So let's make sure that we do. We talked earlier about taking the same sign as the coefficient that's attached to x. So our GCF of negative 8x and plus 2 is negative 2. Negative 8x divided by negative 2 is going to give us 4x. And 2 divided by negative 2 is negative 1. And so here, we should have had a 4x in there. So now our factors are 3x minus 2 and 4x minus 1. Again, when we divided our 12x squared by 3x, up here that should have equaled 4x. So those are our 2 factors for this one. And because there was a little bit of uncertainty there on my end for one section, let's do a check. Let's make sure that everything lines up as it should. So we use the distributive property again, as we always do. 3x multiplied by 4x is 12x squared. 3x multiplied by 1 is minus 3x. Negative 2 multiplied by 4x is negative 8x. And negative 2 multiplied by negative 1 is plus 2. When we combine our like terms, we get 12x squared minus 11x plus 2, which is the original expression. So even though I missed that coefficient 4 in front of x, on the left-hand side of the wall I built, I caught it, and then my check confirmed that that is correct. All right? That's why the check is very useful. If you're ever unsure, do a check and make sure that what you have is correct. And now we get into our final one. And with our final one, you'll notice that we get bigger numbers, and that's okay. It's just something that you have to work with. Now there's no GCF there, so we multiply 12 and 20, and we get 240. And there are a lot of factors to 240. So let's see what we can come up with. And now 6 and 40. We're getting closer and closer and closer. And then we end up with 10 and 24. We ran out of space just a little bit. So I'll have to scroll. And what we want is to find a pair which sums to 31. And when we look at our list, we don't quite have one. So that means that we've missed something. Because there's one more factor. So 13 and 14 don't work. But there is one more factor, which is 15 multiplied by 16. Now we know that it's not going to be two negatives. We know that we can ignore the negatives here, because we want plus 31. So we're not going to add two negatives to get a positive. So the two that add to give plus 31 are 15 and 16. So now we had a big number to factor there. There was a giant list, but ultimately we found the factors that worked. So now we're going to rewrite the original expression, 12x squared. Now we have to decide if we want to put the 15 with the 12 or the 16 with the 12. And it actually doesn't matter in this one. Because 15 and 16 both work nicely with 12. 15 and 16 also both work nicely with 20. Neither works more nicely than does the other. So I'm going to write my 16 first. We'll put our line down the middle and we'll factor. The GCF of 12x squared and 16x is going to be 4x. This leaves us with 3x plus 4 inside the brackets. 15x and 20 is 5, which leaves us with 3x plus 4. Now we have the same thing inside the brackets. So our factors are 4x plus 5 and 3x plus 4. All right, and that wraps up our reference guide on decomposition. It's important while you're working through some of the problems. It may be useful to watch this video or to refer to the notes in your reference guide, but it's also important to remember that it's the same sequence of steps every single time. Your numbers and your variables may change, but it's the same steps each time. Remember, when you're solving these, that you can always check to make sure your answer is correct, even if the question doesn't specify that you have to, by using the distributive property.